All right, chem kids or fans and fanatics, we are talking about atmospheric pressure, and we've been using a vacuum chamber to do so. So I've got a pump over here that's going to suck all the air out of this chamber. Right now, the amount of air, right, and the pressure of the air is the same inside this bell jar, right, as it is on the outside. But to kind of prove to you that we can create a vacuum inside this, we're going to start off with a balloon, one of the simple demonstrations that you see that are used for vacuum chambers. I'm going to put a little air in here, like that, maybe a little bit more. We're going to put this in our vacuum chamber. Now I'm going to put a little beaker inside the vacuum chamber because if you notice, there's a hole right here. And I don't want my balloon to get sucked into the hole, so I'm going to put a little beaker right there, throw my balloon in here, and that way I can get some nice airflow without the balloon covering up the hole. So we're going to close up the vacuum, open up, the vacuum chamber here so that it suck our air. I'll turn on my pump, and before I do this, I want you to think about right now the pressure inside the balloon, right, and the pressure that's outside of the balloon. I want you to try to imagine what the air molecules are actually doing. If you remember, we talked a little bit about how the air molecules are moving around really fast. They're actually banging against the inside of the balloon, and that's what's giving the balloon shape. On the outside of the balloon, same thing's happening. There's all kinds of air in the atmosphere that is banging on the outside of the balloon, and in a way, the inside air balloon molecules are pushing against the outside air balloon molecules, and it's sort of like a reverse tug of war. So, if we remove some of the outside air balloon molecules, the inside air balloon molecules will obviously not have somebody pushing against them. So let's check this out. Let that air back in. Now, mind you, we didn't add any air to the inside of the balloon. We just took the pressure off. Let's do that again. Take the pressure off the outside of the balloon. Suck that air from the vacuum chamber. So, a lot of times when I do this, my students start covering up their ears because they think this balloon's going to be so loud when it pops. In fact, often I'm able to get it to pop. I can try one more time. It's covering up that hole here. Let's try one more time. See if we can so right about now, kids are watching that and they're going, Mr. Schultz, I don't know about this. Keep watching. Gonna pop, but that's okay. So that brings up the question, well, if it did pop, would it be really loud? So with that, let's take a look at something that makes noise. Over here, I have a bell in a bell jar. That's pretty awesome. And if you notice, there are a couple wires that are going to a couple of hooks that are attached to the electronics of the bell. And if I give that bell some power, I'm just going to use a battery here to do that. You can actually hear the bell. So it's not real loud. If I take this, lift up the bell jar, you can hear it. And obviously when I put the bell jar down, it's muffled a little bit. But you can still hear the bell. So the question is, can I hear that if there is no air inside of the bell jar? So let's give that a try. Now I will turn off the pump because I know the pump's going to be loud. I'll turn off the pump when we get all the air out of there. So I'm just looking at a little gauge on the back of my pump. Looks like we're doing pretty good. We've going to actually close off the vacuum chamber from the pump. Turn off the pump so you can hear. It's still moving. I know it's hard to see. It looks like that hammer for the bell is static, but it's actually moving. It's connected to power. And now I'm going to slowly let some air in, and we'll see if we can hear it. So there you go. So because we don't have any air in the vacuum chamber, right, it doesn't allow for the vibration of the bell to create a vibration in the air that would then travel to our ear and allow us to hear it. Because there's no medium, because there's no air for that vibration to travel through, we don't hear anything. Otherwise, right now, the bell is vibrating, and you can't have noise without a vibration, right? But when I get rid of the air, you can't vibrate the bell jar. The only thing that actually vibrates, you can hear it just a little bit, are these guys right here. So yeah, all those movies that you see where explosions are taking place in space and you can hear them, it's just not true to form. That's movie science. Now, granted, if you had your ear against something somehow in space, if you weren't in a spacesuit and you kind of, maybe it was a pole and somebody was tapping on the pole, you could hear that. Or if you were inside the International Space Station, for instance, and there was air in there, of course, sound would travel within that. But if you're out in space, right, which is essentially a vacuum, you're not going to be able to have sound traveling. The last thing I want to show you that most people don't get to see is the relationship between air pressure or atmospheric pressure and boiling point of water. The one thing that people are used to is taking some water, putting it on the stove, and adding some heat to get it to boil. Well, if you can imagine yourself as a little water molecule in here, right? And these water molecules are moving all around, depending on how much heat or energy they have. They're moving all over the place, and of course, the ones that are near the top that have more energy can fly off into the air and become a gas. In fact, these water molecules right here have a certain amount of energy that they're pushing against the atmosphere with, and that's called a vapor pressure. These water molecules, as a liquid, want to become a vapor, and so they actually exert a certain amount of pressure on the atmosphere, but the atmospheric pressure wins. It's so strong that it pushes down on the water and keeps it in liquid form. Sure, some of these water molecules are flying away, and this is evaporating right now as I speak. But if we take away that atmospheric pressure, right? If we take away all that air that's on top of the water, we can essentially free some of these water molecules and do so by getting water or allowing water to boil without heating it up. So again, we're going to turn on the vacuum pump. We're going to suck out the air that's pushing down on the water, and we should see water boil without heat. Let's give it a try. So the first few set of bubbles you're going to see, if you keep it on there real close, are all the dissolved oxygen and other gases, basically the oxygen that the fish breathe when they're swimming through it. You're going to see those gases come out first. We're basically making water flat, and then you're going to actually see the water boil. So there you have it. There's water right now actually turning into a vapor. It's boiling. That's what boiling means. You're actually getting the vapor pressure to equal or be greater than the atmospheric pressure, and it's now able to turn into a vapor. The water is turning into a vapor without any heat. We're going to add back the atmospheric pressure and let some air back in. And of course, that pressure will be pushing back down on the water, and the water stops boiling. Now you might think this water got really hot, but that's not the case. Water's nice and room temperature, just like it was when I put it in there. So then, one of my students brought up a great point. She said, well, what about pop? Like, if I put my pop, she had some sparkling juice. If I put some pop, or if I put my sparkling juice in the vacuum chamber, would it make it flat? And so let's find out. So we'll put a little bit of Coca-Cola. I don't have her fancy sparkling juice that she had. But I'll put a little bit of fizzy Coca-Cola in there. You can see that it is carbonated. Those bubbles of carbonation and the dissolved carbon dioxide that's actually in solution. It's literally dissolved. I know it's weird to think about a gas, right, being dissolved, like carbon dioxide being dissolved in solution, but it is. But if we take that pressure off of the solution, we will be able to release a lot of, pretty much all of that carbon dioxide, and it should go flat. I'm gonna taste test it and find out. I should taste test it before though. Definitely carbonated. And let's see it. Now I'm gonna regulate how much pressure we take off because I don't want it to overflow and make a mess of my vacuum chamber. So I'm gonna gradually get some of that carbonation out. Pretty good. And at some point the carbonation is going to be all gone and we'll just have sugar water that's boiling. We'll have to make a judgment call of when to stop and test it for it being flat. Give it a few more seconds. Thinking we're good. Let's give it a try and see if it's now flat. I'm gonna let that air back in. Again, we're not adding carbonation. We're just kind of putting the air pressure or the atmosphere back on top of it, so it's not actually adding or dissolving gases in it. And we'll give it a little taste test here and see what we got. Tastes like sugary water with like a Coke flavor. It's definitely not Coke. Cameraman, do you want to try this? See if it's, probably doesn't mind drinking out of my cup because he's my son. Yeah, let's get a little, what's that taste? What's it taste like?
Watery Coke.
Yeah, watery Coke. So, anyway, there you have it. There's some experiments that we did in class with the vacuum chamber. We're going to do a lot more. And I hope that helps you kind of grasp some of these concepts that we talked about today because you weren't here. But anyhow, and even if you are not part of this class, hopefully you enjoyed some of the videos or some of the, some of the experiments that we did with the video. If you want to see some more experiments, maybe I'll be making some more. Smash that like button. Is that what they say? You know, subscribe, all that good stuff. I'm not making a bunch of videos, but I will if you want to see more. So anyway, take care. Thanks for watching. We'll see you later.